Alright guys, so yesterday we talked about horizontal asymptotes, and we said that if the bigger degree was on the bottom, like number 4, then you would have a horizontal asymptote at y equals 0. Number 6, if we had the bigger exponent was on the top, then you didn't have a horizontal asymptote at all. But if you look at number 7, where the degrees are the same, then you would divide the leading coefficients. Okay, so in this case it would be 1 divided by 1, which is just 1. Alright, but today we're going to talk about vertical asymptotes, okay? Alright, so here's what you have to do. First thing is you have to factor these like normal. So the top would factor with a GCF of 3, leaving you with x plus 2. And on the bottom, you would need to find factors of 45 that add or subtract to be 4. And that would be positive 9 and negative 5. So you want to check to make sure nothing cancels, okay? And nothing cancels out, so you're good to go. Alright, so a vertical asymptote is what makes this bottom equal to 0. Because remember, in a fraction, you can never, ever, ever have the denominator of the fraction equal 0. So your vertical asymptote would be at x equals, so if I were to take x plus 9 and set it equal to 0, subtract that 9, that would be negative 9. And if I were to take x minus 5 and set it equal to 0, add that 5 over, you would get positive 5. So therefore, you would have a vertical asymptote at negative 9 and positive 5. Doesn't matter the order, as long as the 5 is positive and the 9 is negative. Doesn't matter. Alright, but let's look at number 5. Number 5 is different. So when we factor out the GCF of 3 on the top, that will leave me with 3 and x minus 1. And on the bottom, the factors of 4 that add or subtract to be 3 are positive 4 and negative 1. And what do you notice is that the x minus 1's cancel out. And that's something very special that happens on your graph when those cancel. Okay, so here we go. We have y equals, we have 3 over x plus 4 left. So here we go. So the vertical asymptote is what makes this bottom equal 0. So we have a vertical asymptote at x equals, if I were to set x plus 4 equal to 0, I would get negative 4 as my answer. Alright, now when these canceled out right here, the x minus 1's, when they canceled, so let's say that if I'm taking that out of my equation, then I'm taking that out of my graph as well. So if I'm taking that out of my graph, look at what it says right here. It said label vertical asymptotes. It also said find any points of discontinuity. So points of discontinuity are called holes, okay? So if you take this out of your equation, you take it out of your graph, which means that you're going to have a hole at x equals, so same thing, if I were to set x minus 1 equal to 0 and add that 1, it would be x equals positive 1. So I have a hole at x equals positive 1. So later in this week when we start to graph these, if I took it out of my equation, I have to also take it out of my line. So if I were to draw, let's just say that's a straight line, if I were to draw it at x equals 1, there's going to be a hole right there. So there's going to be a part of your graph that is not filled in because you took it out of your equation because they canceled. Alright, let's look at number 6. So number 6 is the same thing. You've got to see how they factor first, okay? So horizontal is different. If it says horizontal, you're going to say, oh, that's got the biggest exponent on the top, so there's no horizontal. But that's not what these directions said. These directions said vertical asymptotes. So we're going to factor that as x plus 2 and x minus 2 over x plus 2. And looky there, those cancel out. So, hey Marty. Alright, so if those canceled out, then if you take it out of your equation, then you take it out of your graph, which means you're going to have a hole at x equals, now if I were to set x plus 2 equal to 0, I would get negative 2. So what do I have left here? I have y equals x minus 2. Oh my goodness, you don't have a denominator anymore because that canceled out. Technically, your denominator is 1. Let me rephrase that. But 1 can never be 0. And remember, your vertical asymptote was where the denominator equaled 0. Well, ladies and gentlemen, if you don't have a denominator, then there's no way the bottom can ever equal 0, so you will never have a vertical asymptote, ever. If you don't have a denominator, there's no vertical asymptote. No denominator, no vertical asymptote. All right, let's look at number 7. Here we go. We're going to have to factor that, okay? If I'm going too fast, all you have to do is pause the video. All right, so if I were to factor that top, that would be x plus 3 and x minus 2. And on the bottom, that would be x minus 2 and x plus 1. So you notice that the x minus 2's cancel. Oh, whoa, whoa. If you take it out of your equation, you took it out of your graph, what happens? That's a hole at x equals, and if I were to solve x minus 2, set it equal to 0, you would get x equals positive 2, okay? So x minus 2 equals 0, add that 2, that's where I'm getting the positive 2 from, okay guys? Alright, so what do I have? I have y equals x plus 3 over x plus 1, and you have a denominator. So if I were to set that equal to 0, what makes that denominator equal to 0? And it would be negative 1. So you have a vertical asymptote at x equals negative 1. Because any time that this x equals negative 1, it's going to make this bottom equal 0. And remember that, pick a number, any number. So let's just pick 7. So if I do 7 divided by 0, remember, it's going to give you an error. It cannot happen. All right, so here we go. That's your answer. Let's see, we got 2 more to do. All right, let's look at number 8. Number 8, you're going to factor the denominator as x plus 3, x minus 3. Y'all are pros at this factoring stuff by now. All right, so nothing cancels out. So if we're not taking anything out, that means we're not taking anything out of my graph. That means I don't have any holes. But I do have a place where the denominator can equal 0. So I have 2 places actually, and that is where your vertical asymptote is at. And if I were to solve this one for x, I would get negative 3. If I were to solve this one for x, I would get positive 3. And I can simply write that together as plus and minus 3. All right, let's look at number 9. Here we go, number 9. So both of those can factor. So let's just say the direction said horizontal asymptote, guys, okay? So if they have the same exponent and the direction say horizontal asymptote, then you are going to just simply divide the 4 and the 3. So you would have a horizontal asymptote at y equals 4 over 3. But if it said find the vertical asymptote, you have to factor them. So we're going to take out the 4 on the top. So it would leave me with x minus 3. Then I'm going to take out the 3 on the bottom. It would leave me with x minus 3. Oh, look at there. Those cancel out. So I have y equals 4 over 3 as my equation. If I took it out of my equation, I took it out of my graph, which means I have a hole at x equals, if I were to solve that, set it equal, and solve that, I would be x equals positive 3. Okay, on the denominator, is there any way that you could ever make 3 equal 0? There's nothing to move. There's nothing to solve for. 3 is never going to equal 0. It's not true. So if you can never make the bottom equal 0, you will never have a vertical asymptote. So you're just going to have a hole at x equals 3. All right, so here's what you're going to do for the rest of the class period, okay? All right, you should have already started on page 7. If you haven't, go ahead and start on that and finish that up. You're going to work on these 4 problems right here. Now be careful with these directions. The directions say to find the horizontal asymptote. So that's where you've got to look at the exponents. Okay, look at all the exponents. By the way, what's the exponent of this one? There is no x. So if there is no x, that the degree here would be 0. So you have a degree of 0 and a degree of 2. The bigger one's on the bottom. Okay. All right. Then it says find your vertical asymptotes, and your points of discontinuity are your holes. Okay. So find all three of them. Find your horizontal asymptotes, your vertical asymptotes, if any, and find your holes, if any. Okay. So some of your answers may only have one answer. Some may have two answers. And some may have 3 answers, okay? All right, Ms. Forbes has the keys for page 7 and this page, page 9 for these. You are not allowed to take them to your desk. So when you get finished, if you want to check your answers, just take them to Ms. Forbes and ask to check your answers. Then when you finish, before you leave today, you're going to get a checkpoint, okay? If you finish these pages with time to spare, go ahead and grab a checkpoint from Ms. Forbes, and you can go ahead and start on that. If not, then you will get a checkpoint on your way out of class today, okay? So make sure you get one of those, and y'all have a great day. I'll see you tomorrow.